My name is Megan Wengrove. I'm an associate professor at Oregon State University in coastal engineering. And out here we're looking at engineered composite beaches or dynamic revetments. So a composite beach is a natural beach where there's a sandy foreshore and a cobble backshore. They occur a lot in northern latitudes, but a lot in the Pacific Northwest, which is where we're from. So we're trying to test some natural nature-based features and their design here in the lab so that we can provide guidance for engineers to construct these features and design them in the field. We hope the outcome is to provide more resources to engineers out there who are trying to design nature-based solutions for coastal protection. There's really not much literature. There's some reports and some folks that have taken tools from other areas and tried to implement them. So we are hoping to provide design guidance to engineers for designing dynamic revetments in the field.
The only other testing that's been done for seeing what volumes might work, that testing was done without sand. And what we've seen so far is that sand had kind of a big impact. So hopefully this testing is a little bit more realistic for the conditions that we usually see on the open coast and can give engineers a better ballpark of what kinds of volumes they should be using. It's really cool. We've been in here for a long time. I'm pretty tired, and it's really nice to feel like the work that we're doing has a meaningful impact. At the same time, I'm also not surprised. Like, we've known that this is a big kind of hole in our understanding for a long time. People have been building dynamic revetments on the Oregon coast since the early 2000s, and we just keep learning off of the previous projects. And because of limitations on hard structures and places that are continuing to experience coastal erosion, there's a ton of demand for these kinds of structures. And so it's been very clear to us for a while that more information is absolutely needed.
We're looking at a lot of different questions. This flume in particular has been a good size because it allows us to work through lots of different permutations, lots of different configurations of our experiment, so we can hopefully answer lots of different questions. I'm trying to find out one small part of that puzzle, whether the cross-shore sorting is easy to predict given hydrodynamics and profile geometry. I'm hopeful because you can see it, we've sat out here watching waves for hours, and you can see it happening in front of your eyes. It's really interesting, especially when there's a really large wave that hits the face of the berm. As the wave pulls back the backrush, you can see this exfiltration of rocks come down the berm, be transported offshore, only to be pushed back by the next wave, but you see these mechanisms in play, and it's been really interesting.
This is a really awesome lab. Everybody's been super, super nice, super welcoming, super helpful. We definitely could not have done this experiment without any of them. And it's been really cool to get to meet other people from ERDC as well, to see what it's like to be at an engineering research facility, because I've never really gotten to see that before. And so talking to people about their jobs and the projects that they're working on and their friends' projects and what they're working on gives me a better picture of what's going on at the whole of ERDC, and that's been really cool.
Having partners like Oregon State University is a real, something I'm really grateful for and a great opportunity for ERDC. And so to partner with them is only aiding ERDC and expanding our capabilities. And so as we move forward, we look forward to continuing this collaboration, but also what comes out of this research, what comes out of this effort, and what we can learn and hopefully, transition to the field, transition to the districts so they can, design better, design faster, and improve the function of our coastlines for, everyone. ERDC, we have probably one of the largest groups of coastal engineers and coastal scientists in the world, but at the same time, there's a lot of expertise out there that's always growing. The science, the field is always growing. And so, you don't want to operate in a vacuum, you don't want to operate in a closed environment. So it's always important to always have your hands out there and interacting, learning from others, they're learning from you, and that just advances everyone much quicker. So that collaboration is really what grows, and it's a huge part of what we call the power of ERDC.